Okay. This is take two. So I just did the stream, and then at the end, I realized I forgot to share my screen. So I'm just going to go ahead and run it back. That kind of stuff happens. You know, do your best to try to avoid that kind of stuff. But I'm just trying to confirm that it's actually pushing. Comment, gentlemen. Okay. All right. So, all right. Well, take two. Let me start my timer. Start. All right. Oh, so you have to bear with me. I literally just did this, and then at the end, I realized that hmm, I realized that I didn't share my screen, so it picked up my audio, and I don't have a copy of the video anywhere. So just gonna have to make it again. Um, let me hop here, and let me do something real quick. If I can get to it. Let's see, we're working on exam one. So this one, I want to delete the results. I think I need to go. Ooh, I might be able to do it. Let me see. Here it is. Okay, this one. Okay, I think we're good now. Let's see. All right, yeah, sorry about that. So yeah, um, so that way it's like a fresh slate. Okay. So yeah, again on my end, I literally just did this, and so I'm a little bit exhausted. So you just have to bear with me. I'm having to redo it again. I did the recording and I forgot to share my screen, so none of my images pushed through. My audio is there, but none of the images are there. So I'm just going to run it back. So with that though, I have my microphone in, so I can't hear you like audibly. If you have questions, you have to put your questions. Just type them in the chat, and we'll be sure to get them addressed. Okay. All right. So let's hop over here. Generate. We'll start with question 86. So this question comes from section 1.5, question 62. I think we're good, yeah. It says for the function, find the points on the graph at which the tangent line is horizontal. So in other words, take the derivative, set the derivative equal to 0, and we're just trying to find those values of x and make the derivative 0. So the derivative here, like, is going to be a 2x. So that means basically at the origin, right? Because we say 2x equals 0, then x equals 0. So when x is 0, the corresponding y is a negative 3. So 0, negative 3. And if you think about it, we have a U-shaped curve that's been pulled down by 3 units. So the tangent line is going to be a flat horizontal line at 0, negative 3. Let's go to question 113. This comes from section 1.6. It says find the derivative in 2 ways. Okay, so they're saying after multiplying it out, so they want us to expand it. All right, if we FOIL, that's going to be what, 45x squared? Ten plus 27 is 37. And a 6. Oops, 6. So then if we take the derivative, oh, that's my speaker over there. Just turn this volume down so it's not distracting. Okay. Whew. I think it's just like 45x squared. 37 and 6. So now when we take the derivative, we get what, 90x plus 37. Okay. So then if we use the product rule to take the derivative, that's what, the first times the derivative of the second plus the second times the derivative of the first. So the first, the derivative of the second, like it's a 9. Plus the second times the derivative of the first is a 5. $45 plus 45 is 90x. Oh, okay. 45, 27, 45, and 10. 90, 90x plus 37. Okay. So 45, 27, and 10 is 37. 2AX plus B. Compare the results using the product rule. After distributing in part B, to what, 45 plus 10? Is that what they want? Like they've been a little bit extra here. Let's see. Part B. Mhm. Oh, 90. Okay. So 90x plus 37, like is like making us say the same thing over and over. That's what it feels like anyway. 90x plus 37. Okay. Let's generate. Let's go to question 49. So this question comes from section 1.3, question 30. Find the simplified form of the difference quotient and complete the following table. I think this one was just like, I think it was just -3. So I just spared the details here for the difference quotient. We're more than likely we'll have another one, and I'll go into more details. I really just took the derivative because the derivative was a constant. Um, there's actually more to that one, but I'll save it for when it pops back up again. So then, no matter what x value we choose, the corresponding the outcome, the difference quotient is always going to be a -3 in this case. Okay. Let's try another one. Oof. Let's go to question 20. This comes from section 1.2, question 3. Okay. The limit is x approaches one of this. Is there a graph or something? No. I'm thinking it's D. Yeah, let's just go D. Oh, let's see. I thought that's what we did. Is x approaches A of that is the same as that? Yeah. How is it different? Let me see. It's true. Oh, was it? Oh, it was okay. I see. It's false because it was applied improperly, right? Because 6 squared is not 12. 6 squared should be 36. Okay, I see. What's the difference between these guys? Okay, I think it's C, right? Okay, let's just try another one. Generate. Go to question 26. So this comes from section 1.2, question 28. The initial substitution yields this. Simplify it. Okay. So if we plug in 196, it gives us 0/0. What I'm thinking, I'm getting this thing of like, okay, let's try multiplying by like the conjugate. Okay. So let's try to take some notes here. If we multiply the top by the conjugate, will that help us? We could also do the denominator as difference of squares. We got the square root of x squared, and I think it's a 14 squared. So then we should get the square root of x plus or minus 14. So then root x minus 14s are going to cancel. We're going to be left with 1 over root of x plus 14. So we said 1 over root of x plus 14. So then 1 over 28. If we plug in the 196, we'll get 1 over 28. Okay. Let's go to question 12. And again, I have my microphone in, so if you have questions, I'm not going to be able to hear you audibly. You're going to have to type your inquiries in the chat, and we'll do our best to get them addressed. Okay. I'm sorry. So this question comes from section 1.1, question 65. We're asked to graph the following function and find the specified limits. So we have a reciprocal function. If we use transformations, it will move it left 2, did a vertical stretch by a factor of 9. So we can at least eliminate B because that one didn't move left. I think all the others. Oh, we can eliminate A and B because those move to the right. Ours needs to move left. I think it's D. So for instance, if we let x be -3, we should get a negative result. And we do. If we let x be -1, we should get a positive result. And we do. Right? So I chose a few test points. Should be D. So the limit as x approaches -1. -1 is in the domain, so we can just plug it in. Looks like we get a result of 9. But when x is a -2, that's our asymptote. So that limit's not going to exist. Okay, let's go to question 94. This comes from section 1.5, question 11. We're asked to find the derivative, so let's say we have to apply the chain rule. The 3 comes down. X to the power 12. Minus 1. So now it's squared. And then we have to say times the derivative of the inside function, 12x to the power of 11. Okay. Generate. Let's go to question 8. So this question comes from section 1.1, question 48. Use the graph of 8 shown on the right to find the limit. Okay, as x approaches 0. Right? So the limit from the left does not equal the limit from the right. So we'll say the limit does not exist. I can get my image back. Here we go. It's past my bedtime. Let's generate. Let's go to question 66. Oh, I gotta stand up. Okay. Let's see. Finding the equation of the line to the tangent graph at this point. So what we need to do is find a derivative. So the derivative is going to give us the slope of the tangent line. So then we use the slope and the given point to find the equation of the line. Okay, so let's take some notes. So the derivative here, what is it, a negative 16 x? So then when x is at 2, looks like we get negative 32. Okay, so we have our slope, we have our x and our y. So y equals mx plus b, a negative 32 times what? 2. We're solving for b equals negative 33. Okay. What is that? A negative 64, 64 minus 33. 24 and 7, 31. 64 and 31. We're getting a positive 31 for B. Our slope was a negative 32. Okay. I'm gonna get rid of my notes. Okay, let's just go with it. Ho, ho, ho. Sorry. Okay. Let's generate. We can go to question 4. This comes from section 1.1, question 29. Okay. So we want to find the limit as x approaches -7 from this graph, right? So the limit from the left equals the limit from the right, and they both equal, looks like it's a 1. Okay. Let's go to question 14. Okay. This question comes from section 1.1, question 77. So we have a piecewise function. It's basically multiple graphs on one chart. Um, we graph each one like normal, but then we restrict each graph based on the given domain. Let me see. So for instance, when x is 2, that would have been a 1, into 1. That would have been a 4. Okay. I'm thinking it's C. Oh, okay, let's see. All right. So that would have been a 1. They should be connected. Oh, yeah. Let's see. From 2 to 4 it needs to be a flat horn. It needs to be 1. Okay. Yeah, I'm not, for whatever reason, I felt. Oh, okay. It could have been. I didn't check the third one. It could be D. Normally, let me see. It's 2, 6. Yeah. Let's go with D. Right. I just assumed the third one behaved similar. Let's go D. Yeah. Okay. Select the correct choice if necessary. Fill in the box. The limit as x approaches 2. So from the left, the y value gets closer to 1. From the right, y is 1. So we would say the limit there is 1. But for 4, on either side of 4, the y values approach different numbers. So we would say that the limit does not exist. Again, yeah, you have to bear with me. Let's generate. Let's go to question 90. So for this function, I find the points on the graph at which the tangent has a slope of 5. So we just want to basically take the derivative and set the derivative equal to 5. So we can take some notes here. So if the 3 comes down, that's going to be what? X squared minus 4x plus 8. We want to set this equal to 5 and solve. So then we'll get what? X squared minus 4x plus 3 equals 0. Okay. So it looks like we can factor this guy. So x minus 3, x minus 1. Okay, equals 0. So then we get what? 1 and 3 when x is a 1 and when x is a 3. And then we need to find the corresponding y values from the original. So we got 1 and 3. One comma something, and then 3 comma something. Okay. Let's see. So if we plug in a 1, that's a third minus 2 plus 8. Let me see. That's 10. That's an 8. 8 and a third. So 20, 25 over 3. And then when x is a 3, 27 divided by 3 is 9. 9 minus 18 is a negative 9. 24. 14, so 15 plus 2 is a 17. So again, all we really did was took those values of x and plugged it in for the corresponding y to find the corresponding y. Okay. Let's go to question 25. This question comes in section 1.2, question 24. The initial substitution of this is 0, 0. Okay, so it looks like we need to factor this guy. Okay, I kind of need to write this one out. So what I'll do, I'm going to get, I just need to, I'm going to get a copy of this guy and we'll work it out. Okay. So I'm going to use this technique. All right. So we got this 2x squared plus 3x minus 14. I'm going to use this technique called the AC method of factoring. I'm looking for two numbers that multiply to give me a negative 28. Right. That was what? A 2 and 14. That's 2 and 7. So what I'm going to do is go through all the combinations of the factors of 28 and stop at the line that adds up to 3. Okay. But those two add up to 27, so that's no good. We can do a 2, right? If we use this 2, we still have 14 left over. But those add up to like 12, so those are not the numbers we're looking for. There's no 3, but we can do 4. If we do 4, we get a 7, so we get a 3 left over. These are the two numbers we were looking for. You have to, my voice is just, it is what it is. I can't, like, you know, and again, if you have questions, I'm not going to be able to hear you right now, but if you type it in the chat, we'll be able to address your questions. Okay. So we're going to rewrite this guy using those numbers we just found. I'm going to intentionally put the 4 next to the 2 and the, let me think about this. Oh, wait a minute. Wait a minute. Oh, that's supposed to be what? That's 7 right here. Because they multiply to give us 28 and add to give us 3. Okay, there we go. So yeah, I'm going to put the 4 next to the 2 and the 7 next to the 14. That's going to be what? Minus 4x plus 7x minus 14. So then I'm going to use this AC method of factoring. When I have 4 more terms, I'm going to use, factor by grouping. We can factor out a 2x here. We're going to be left with x minus 2. 2x squared minus 4x, right? And then the hint is we're looking for another, this guy again over here, and we'll get that if we factor out 7. Okay, so then we have a common binomial factor. And then we're left with the 2x plus 7. Okay. So now at this point, we have the limit as x approaches 2. That numerator factors into this guy. And the denominator factors into x minus 2 times x plus 2. Okay. So then this is canceled by this. And now at this point, now we can just plug in x equals 2 because 2 is in the domain here. So that's what, 11 over 4. Okay. Let's go to question 103. Okay, so it looks like we have to apply the product rule here. Now, I feel like it might be a little bit easier if we just go ahead and distribute that instead of doing the product rule, just distribute and expand it and then take the derivative. So I'm going to take some notes here. What is it? Just going to be a 4x for the first term minus 16 plus 36. Let's see. We got a negative 3 plus 1 is a negative 2. Minus 28 x to the negative 3. Okay. Then let's take the derivative of this guy. That's going to be a 4. The 16 is gone. Minus 72. X to the power of what, negative 3? 60 and 24 is 84, so plus x to the minus 4. Okay. So I'm going to go with this result. Okay. Let me check my clock real quick. Give me just a moment. Okay, it's not too terribly bad. Again, you have to just bear with me because this is like my second time doing it. I created this before, and like I said, I didn't share my screen, so I just turned around and went on and did it again. So this is approaching like hour 3 for me. Okay, anyway, let's keep going. Let's go to question 125. So this question comes from section 1.7, question 49. So given this f and this g, find f of g, f compose g prime of 1. Okay. So I think what we can do here is say f prime, let me think, because it's essentially the chain rule, right? We could say f prime times g prime. I think that'll work. Let's just do that and see what happens. So first, let's do f prime. So the 1/3 is going to come down. It's going to be a u to the power negative 2/3 times g prime. Like it's going to be 24x. Okay. 1/3 u to the negative 2/3. Mm-hmm. And we want to evaluate this when x is a 1. Okay. We're going to say equals. So 24 divided by 3 is what, 8? And then when x is a 1, our u is 14. Negative 2/3. Okay. Let's see if we can simplify this down further. I think I'm gonna just go with this result. So let me get rid of my notes. Okay. Let me see. All right. Just okay. Let's go to question 29. So this question comes from section 1.2, question 41. Find the indicated limit. So because 6 is in the domain of the function, we can just plug it in. So square root of 39, 29. It's just a square root of 29. So again, you know, if you have questions, I'm not going to be able to hear you audibly. Just have to type your questions and inquiries in the chat, and we'll make sure to get them addressed. So we'll go to question 82. Okay. So we have what, 1/3 x? That first term is just a third. I get this thing to work. Okay, 1/3. But then the second term, that's really what, 3 times x to the -1. So double negative becomes positive. So we're going to say +3. So and then subtract 1 from the power is x to the -2, x to the power of a -2. So to question 127. So given the total revenue function here and the total cost function here, both in thousands of dollars, find the rate at which the total profit is changing when X items have been produced and sold. So it looks like we got to take the derivative, profit. Okay, so essentially, profit is going to be what? Revenue minus cost. We just need to take the derivative, which I'm really just avoiding because it looks like a pain. But anyway, let's just do it. So let's see. If we take the derivative there, the 1/2 comes down. So that's going to be what, 350? Now times. We have to apply the chain rule. That's going to be x squared minus 0.3x. Okay. That's going to be to the power of a -1/2. And then we need to say times the derivative of the inside function. So it's going to be a 2x minus 0.3. Okay. So that's r prime. Then we need to say minus c prime. 1/3 comes down. I'm going to leave it as 1400 over 3 for now. The inside persists. So that's x squared plus 5. So that's a -2/3 to the power of a -2/3. Okay. The derivative of the derivative of a constant is 0. Also, we need to say times the derivative of the inside function. So times of 2x. Okay. Trying to see if I can get anything to cancel. It's a little bit extra. We should try to simplify. Sometimes they'll take the longer results like this because it's not really a lot that's canceling. There are some like terms that we can combine. I'm gonna I'm gonna go with this. Okay. Yeah, that's why I was like pausing so because I was just like, ugh, this one has like a lot of like annoying moving parts. It's not difficult. It's just you have to like slow down and like really I should have written it out, but I just didn't do that. But yeah, okay. Okay, let me check. So we say no. Okay, let's keep going. Let's generate. Let's go to question 78. This comes from section 1.5, question 27, find the derivative. So we can rewrite it as a negative exponent. The negative exponent comes down. So double negative becomes positive. 8 times 2 is 160. And then it's going to be x times x to the minus negative 9. Let's go to 77. Okay. All right. So the power comes down. Subtract 1, we get a negative 0.9. Go to question 12. Okay, so since we've done 12, let's do 13. So we're asked to graph the function and then find the specified limits. 3x plus 5 and x. So what happens at 1? That one is 9, and that's a 1. So a negative 1. So if we plug in negative 1, it's going to be a 2. That's going to be a negative 1. 2 and negative 1. So it should be D. Let's see. So the limit as x approaches negative 1 from the left. So if we plug negative 1 into equation 1, that's going to give us 2. Mm. The limit as x approaches negative 1 from the right. It's just going to be a negative 1. So then because the left-hand limit does not equal the right-hand limit, we say the limit does not exist. Okay, sorry. Hmm. Let's go to question 83. This question comes from section 1.5, question 50. Given this f, find f prime of -1. So the derivative here looks like it's going to be a 6x minus 3. So negative 6x minus 3 is a -9. Okay. Hmm. Okay. Let's generate. Let's go to question 22. This question comes from section 1.2, question 11. I use the theorem on limits of rational functions to find the following limit. Because -6 is in the domain of this function, we could just plug it in. So we'll get 36 minus 8 is what, 28? Okay, we can do question 3. Use the graph of f to find a given limit. When necessary, state the limit does not exist. The limit is x approaches 5 of this function. So from the left, uh-oh. Come on. Right? From the left and the right, the y values are approaching the same number, which is what, 6? So we're just going to put 6 there. Let's go to question 121. Okay. So we're applying multiple rules here. The main one, the first one is like the chain rule, so the derivative of the outside function. So we're going to have what? 1/2. We'll do parentheses 8 minus x, 3 plus x. And now it's to the power of a -1/2. And then we need to say times the derivative of the inside function. So when we go to take the derivative of the inside function, we need to use the quotient rule. Quotient rule. Sorry. Okay. So the bottom is 3 plus x. The derivative of the top is -1. We'll just go ahead and change it. So it's going to be a negative. It's going to be a negative. Okay. So we've done the bottom times the derivative of the top minus the top. The bottom times the derivative of the top minus the top times the derivative of the bottom. Derivative of the bottom is a 1 over the bottom squared. Okay. Let's simplify. I'm just going to keep that part on the left. I'll come back to it. It's like a negative 11. That's it, right? Because we have minus a negative x minus negative x. So they go to 0. The denominator is still 3 plus x squared. Okay, so I think that's the derivative of the inside. So what I'm going to do is get rid of my notes to extra parts. That goes and that's gone. And that guy persists. We could write that as a negative 11 over 2. Yeah, I'm going to just go with it. Okay, we can do 120. Oop. Okay, let's just do the chain rule. So the negative 4 comes down. That's a 4x plus 3. 4x plus 3. 3x minus 1. And that's now to the power of a negative 5. Then we need to say times the derivative of the inside function. So chain quotient rule. Oh no. How do I turn it? I might have to redo it. Darn. That's annoying. All right. So 4x plus 3. 3x minus 1 to the power negative 5. I'm going to say times. So we need to do the derivative of the inside function. There it is. So at the bottom, 3x minus 1 times the derivative of the top is going to be a 4. That's going to be 12 minus 4. Okay. So we said the bottom times the derivative of the top minus the top. That 4x plus 3. Times the derivative of the bottom is a 3. So that's going to become a 12. That's a 9. And actually, that's a negative 9 and a negative 12. Okay. All over the bottom squared. 3x minus 1. Okay. Let's see. So the 12s are going to cancel each other. And those negative 4 and negative 9 is negative 13. Okay. So what we did here, we did the chain rule, right? The derivative of the outside function times the derivative of the inside function. We got a -4 and a -13 to give us a positive 52. So I'm just going to account for that. Okay. Let's go with it. Okay. Then we got about 10 minutes left. Let me check. Oof. Right at 10 minutes. Okay, cool. So actually, we'll hang out for about 5 more minutes. We'll do one, maybe two more questions, depending on how long they take us. Generate. Let's go to question 47. So this comes from section 1.3, question 19. Average rate of change, just find the slope between the 2 points. I think I'm gonna just use my calculator. Okay. So what I'm gonna do is go to my y equals 1/4 times x squared plus 1/2 times x. Okay. So all we're going to do is like find the slope between the 2 points, y2 minus y1 over x2 minus x1. So I want to call on this function. I want to evaluate this function when x is what, 9? And I'm going to insert some parentheses. So that's our y2 minus, we want to evaluate this function when x is 3. Close off my numerator, divided by 9 minus 3 is what, 6. So I'm just going to do 6. I'm going to hit math as a fraction. 7/2. Okay. So again, like if you have questions, you have to type it in the chat. Let me see. Let's try to do one more. Hopefully it's just let's just do one more and we'll call it a day. Okay, 51, 8, 9, 10. Okay. So this question comes from section 1.3, question 37, business economics. Use the graph to estimate the average rate of change from these times. So 1994 to 2000. So 94, 7, 8, 9, 10, 4 to 2000. So 2000 look like it's 18, 19, 20, so 16%. So no, it was just 16. 16 over. So 4 and 6. 16 divided by 6, whatever that number is. Two decimal places, so 2.67% per year. Okay, I think hang on. Yeah, we're good. Okay. Check. Okay. 2000 to 2006. 2006. So 2000 was 16. 2006 looks like it is 24. Right. So then we can do 24 minus 16 divided by 6, because it's 2006 minus 2000. I'm gonna hit math as a fraction. The decimal is at 1.33% per year. So 94 to 2006. 24 divided by 12 is at 2% per year. All right, gentlemen. So with that, we're going to go ahead and end the session here. Again, I'll probably pull out my microphone in just a moment. So if you want to unmute yourself, once I finish closing out, then you can, and we can talk audibly if you need to. So today we just focused on chapter 1, right? And then on Wednesday, we'll pretty much be doing the same. We'll focus on chapter 2. If you don't have any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, take care and peace. And I'm removing my microphone now. Take care, gentlemen. Peace.